Welcome! My name is Raina Fitzgerald, and in this lesson we're going to look at the Cartesian coordinate system and linear equations. The Cartesian coordinate system is made up of the x-axis, so here's our x-axis, and a y-axis, and here's our y-axis. The point of intersection of the x-axis and the y-axis, that is this point right here, is called the origin. The x-axis and the y-axis subdivide our area into 4 regions: here, 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 and here. These regions are called quadrants. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Our axes are labeled with tick marks. This is tick mark number 1 on the x-axis. This is tick mark 2. Here we have tick mark 3, and these are locations on the x-axis. Our origin is location 0. And as we go to the left of the origin, our tick marks become negative. So going to the left, our integer values, because the tick marks are integer values, decrease, and going to the right, they increase. On the y-axis, as we move up, our tick mark values increase. This is location 1, here's location 2, and here's location 3, and it continues on up. Again, the y value at the origin, like the x value, is still 0, and as we go below the origin, our y values are negative. -1, -2, -3, and so forth. As we head down on the y-axis, our values get smaller and smaller, or more negative. As we head up on the y-axis, our values get larger. And as we head to the right, on the x-axis, our values get larger. And as we head to the left on the x-axis, our values get smaller. The Cartesian coordinate system allows us to find locations of points. For example, let's say we have a point right here. And we'll say this is point A. And we want the location of point A. Well, if we go down from point A until we touch the x-axis, we see that the location on the x-axis is 3. And if we go horizontally to the y-axis, we see that the location on the y-axis is 2. So point A has a location on the x-axis, which is 3, and on the y-axis, which is 2. And we write this with a left parenthesis, then our x location, a comma, our y location, and then we close the parenthesis. This is called an ordered pair. The ordered pair gives us the x location and the y location, such that if we draw a vertical line through our x location and a horizontal line through our y location, the point where those two lines intersect is point A. The 3 in our ordered pair represents our x-coordinate. The 2 represents our y-coordinate. Let's graph another point right here. We'll call this point B. Let's map point B to the x-coordinate and the y-coordinate. To the x-coordinate, it maps with -3, and to our y-coordinate, it maps with -2. So the ordered pair for B is -3, -2. Let's try mapping a point in quadrant 2. This will be point C. Let's make point C right here. Now let's map point C first to our x-coordinate at -2 and to our y-coordinate at 2. Point C is located by the ordered pair -2, 2. Lastly, let's put a point in our fourth quadrant. We'll put that point right here, and this is point D. Now let's map D to its x-coordinate and its y-coordinate. D maps to 4 on the x-axis and -2 on the y-axis. The ordered pair for point D is x is 4 and y is -2. Now let's look at the standard form for a linear equation. That is, an equation that represents a line. When we talk about the standard form for a linear equation, we start by defining a, b, and c. A, b, and c are constants. They represent some real number value that never changes. It's constant. Now the form for the equation is a times x plus b times y is equal to c. Let's move this up. Keep the following in mind. X and y are variables that can have many, many values. The x represents the x-coordinate and the y represents the y-coordinate for any point that's located on this line. Let's try an example. Let's take the line 2x plus 3y is equal to 6. So our constants are 2, 3, and 6, where a is 2, b is 3, and c is 6. X and y have a variable, they're variables because they can be a wide range of values. For every x there's a corresponding y value, such that together they make an ordered pair that would graph as a point on this line. Let's take this up a little bit, and what we're going to do is I'll put it up here, let's make a table of values for all possible x and y values on this line. So I'm going to make, we'll make a t-chart. Okay, this is our t-chart right here. This column is our x column, this column represents our y column. So for every x value there's a corresponding y value, and that's going to represent a point on the line. So let's make x 0. Well, when x is 0, we have 2 times 0 is 0. And so what happens here is we basically lose this 2x term, and we end up with 3y is 6. If we have 3y is 6, then both sides multiplied by 1/3 gives us y is 2. Let me work this out down below. Let's take our original problem and we'll do this in red. If I have 2x plus 3y is equal to 6, and I set x equal to 0, I have 2 times 0 plus 3y equals 6. Well, 2 times 0 is 0, so I get 3y equals 6. And if I multiply both sides by 1/3, 1/3 times 3 is 1. 6 times 1/3 is 2. So my corresponding x value will be 2. Now let's set y equal to 0. I'll change my color up. If y is 0, and I start with 2x plus 3y is 6. Okay, now let's replace the y with the 0. So we have 2x plus 3 times 0 is 6. Well, 3 times 0 is 0, so we get 2x is 6. And if we multiply the left and right hand side by 1/2, we get x is 3. So when y is 0, x is 3. So now I have 2 points that are points on my line. Okay, so let's take a look at our first point, 0, 2. That is the ordered pair. When x is 0, y is 2. And I have drawn a graph down below, right here. So when x has a value of 0, y has a value of 2. The point we get is right here. When x is 0, y is 2. Now let's go up to the t-chart again and look at our next point. When x is 3, y is 0. That's the ordered pair. When x is 3, y is 0. Let's go back down to our graph now, and that's the point right here. When x is 3, y is 0. Now let's go find another point. Let's imagine that here we'll set x equal to 1. Well, when x is 1, we end up with we have 2x plus 3y equals 6. And if we put a 1 in for x, we have 2 times 1 plus 3y is 6. And if we subtract 2 from both sides, this is our 2, we have 3y is equal to 6 minus 2, or 4. Divide both sides by 3, and we have y is equal to 4/3, which is the same as 1 and 1/3. So when x is 1, y is 1 and 1/3. So our ordered pair is when x is 1, y is 1 and 1/3. Let's go find that on our graph. X is 1, so I'm going to come up from my x value, and y is 1 and 1/3, which is about right here. So here's my point. X is 1, y is 1 and 1/3. Now let's try this for when y is 1, what is x? So I'm going to go back to my original equation. 2x plus 3y is 6. And when y is 1, we have 2x plus 3 times 1, which is 3, is 6. If I subtract 3 from both sides, or add a negative 3, I get 2x is equal to 3. Multiply both sides by 1/2, and x is 3 over 2, which is the same as 1.5. So I'm going to come back up to my t-chart, and here when y is 1, x is 1.5. And let's go find that on our graph. When y has a value of 1, x has a value of 1.5, and that puts us at a point right here. And I hope you can notice that these 4 points that I've graphed, which are these 4 points here, let's write that last point in. When x is 1.5, y is 1. So here, these are our 4 ordered pairs. 0, 2, 3, 0, 1 and 1 1/3, 1.5 and 1. These 4 points I've graphed here, and I hope what you can see is that these points, if I draw a line through them, are collinear. They all fall on the same line, and I've just drawn that line, and that line, which is right here, represents this line right here. Let's put a box around our original equation. Here's our original equation. 2x plus 3y is 6, and when we graph this line, we get this line right here. And we tested it with these 4 points, but if you look at this line, you can see that there are actually an infinite number of points that fall on this line, which is represented by this linear equation, 2x plus 3y equals 6.